Hey everybody, welcome back to this course. In this video, I just want to go over how to simulate alternating current on LTSpice. So I'm going to start things off by opening this blank schematic here. I'm going to put down a voltage source. And I'm going to put down a resistor. And we're going to connect these two up. Nothing fancy yet, right? So we've got our voltage source, we've got our resistor. I'm going to set this to 100 ohms. And I'm going to right click the voltage source itself. And I'm going to click on advanced. And so now we're moving up in the world. We're not using a regular DC value, but we're going to use the sinusoid. So we don't need any DC offset. We are going to set the amplitude. And this will be like setting the amplitude of a sinusoid. So I'm just going to set it to 5 and we'll see what happens. And we're going to specify some kind of frequency. And we're not going to worry about this time delay or theta or phase phi or number cycles. But I'm just going to go ahead and click OK from here. Now I've got this 5-volt sinusoid, and we'll go ahead and run this and well, put down a ground first, and then also we'll run it for start at time 0, and we'll go for 1 cycle. So we're going at 100 hertz. So 1 cycle happens in about 10 milliseconds, well, in exactly 10 milliseconds. So we'll run that for 10 milliseconds here. So now we're running, we've got our alternating current, right? And I had a little discussion video on what alternating current is, but basically, instead of just a positive or constant value here, current flows clockwise and then counterclockwise, right? So it starts off when this voltage source is like positive, right? The current is going to flow from positive to negative, but then the polarity at some point, right? We'll just plot it here. So it goes up, the voltage goes up, comes back down to 0, and then it becomes negative, right? So the polarity of this voltage source effectively switches. And then at this point, after about 5 milliseconds, the current flows in the opposite direction. So this is right how you'd go about using a alternating current source. And as we discussed in a previous video, this is 5 volts peak, right? So there are different ways of specifying how many voltage or what the voltage is of an alternating current source. You've got VP, V peak to peak, and then VRMS. Since we're going up 5 volts, we can specify this as 5 volts peak. Alternatively, right, we're going from one peak to another peak. There's a distance of 10 volts. So that would be 10 volts peak to peak. And then RMS is a little bit different, but a little harder to quantify. But we'll talk about, we talked about that previously. So hopefully that makes sense, right? And just as a reminder, you click on these nodes to plot the voltage, but you would click on a source to plot current, right? So if I wanted to go here, I can backspace and delete this, and then I can click on the voltage, the resistor element, and it would plot the current here. And we can actually plot both of these at the same time too, which is kind of interesting. You can see that right now that they're overlapping. But if I were to add another resistor here, right, so this would behave kind of like a current voltage divider. So I could put maybe 200 ohms there, run it again, and you can see the current through R1 has decreased slightly there. So hopefully that helps you get started with the quiz, right? It's just adding this alternating current source to a lot of the different simulations that we've already ran through. Thanks for tuning in. See you guys in the next one.